industry professionals. I am
I am
confident that today's expert talk will provide valuable insights into the future of sustainable mobility and help us better understand the role this technology will play in the years ahead. I sincerely thank our distinguished speaker for sharing their expertise and all participants for joining this webinar. I encourage everyone to actively participate in the discussion. With these words, I welcome you all once again. This is the webinar Vibration 6. Thank you.
Thank you.
Thank you, sir. May I now request our moderator, sir, Dr. Anand Bhushan, sir, please introduce the panelists of the today's session, sir.
Thank you, sir. Good afternoon, everyone. JLC has organized the Institute of Engineers technical webinar on EVs versus hydrogen vehicle under the aegis of Production Engineering Division. We have two panelists. First one is Dr. Jain, none other than Chairman of JLC. Dr. Jain has motivated organizer, professionals, skilled researcher, and administrator, having 35-year experience of the various positions in technical education department, working as a head of the mechanical engineering department of technical college, Dr. Jain having 16-year experience of professional duties of administration, supervision, counseling, training development, technical project management, and budgeting. His technical skill includes curriculum development, technical expertise, individual and group training, authoring and presenting research paper in national and international journals conference, and he has the many editors and members of the many editorial boards of the national and international journals. Dr. Jain having the strong leadership skill, able to prioritize, delegate tasks, and make sound decisions, creative, resourceful, and flexible, able to adopt changing, prioritize, and maintaining a positive attitude and strong work ethics. Dr. Jain, skilled communicators and able to synthesize and deliver the complex information to diverse audience. Dr. Jain, known for his interactive teaching style that encouraging the student participation and enthusiasm while facilitating the learning. Dr. Jain holds PhD in mechanical engineering and MBA in finance management. And we have other speaker, Dr. Pramod Kenkar. Dr. Pramod Kenkar is an associate member of the Institute of Engineers and currently serves as a lecturer in Mechanical Engineering Department, Kalaniketan Polytechnic College, Jabalpur, India. He has over 25-year experience in teaching and has published more than 12 articles, conference paper, and book chapters in reputed journals. He has a bachelor degree from Guru Ghasidas University, Bilaspur, and a master's from Rajiv Gandhi Pradyogiki Visvyavidhalaya, Bhopal, and PhD from NIT Raipur. His area of particular interest including refrigeration system, industrial engineering, and educational management. We have both two keynote speakers having the various experience in mechanical engineering and automobile sector. Now I hand over to Dr. Raju Jain.
Am I audible?
Am I audible?
Yes, sir.
So, our today's webinar has two aspects. One is electrical vehicle, other is hydrogen vehicles. So, I'm inviting Dr. Pramod to start his presentation with the electrical vehicle.
Good afternoon to all of you.
Good afternoon to all of you.
Thank you, Dr.
Thank you, Dr. Jayan,
for
for
giving
giving
me
me
this
this
opportunity.
opportunity.
Electric
Electric
vehicles
vehicles
are the
are the
vehicles
vehicles
which
which
are
are
removing
removing
the
the
challenges
challenges
of
of
environmental
environmental
and
and
traditional
traditional
fuels.
fuels.
These
These
electric
electric
vehicles,
vehicles,
we
we
have
have
some
some
contents,
contents,
overview,
overview,
history,
history,
types
types
of
of
electric vehicles,
electric
why there
vehicles,
is a pull
why
for
there
electric
is a pull for
vehicles,
electric vehicles,
how does
how
electric
does
vehicles
electric vehicles
work,
work,
advantages of electric vehicles,
advantages of electric vehicles,
argument against
argument
electric
against
vehicles,
electric vehicles,
incentives to buy
incentives
electric vehicles,
to buy electric
future electric
vehicles,
vehicles,
future
and the
electric
conclusion.
vehicles, and the conclusion.
Now we will start
Now we
with the
will start
overview
with the
of
overview
electric vehicles.
of electric vehicles.
Presently, these are the hot
Presently,
items in
these
the
are the
auto
hot
world,
item in the
with
auto
many
world,
auto
with many
manufacturers
auto
offering at least
manufacturers
one model.
offering at least one model.
Improved versions
Improved
are on the
versions
near
are on the near
horizon,
horizon,
two
two for good
reason.
reason.
Electric
Electric
vehicles
vehicles provide environmental advantages,
and
and
even
even
though
though
they
they
may
may
carry
carry
a higher
higher
price
price
tag
tag
initially,
initially,
tax credits and lower operating costs often balance out the initial investments. Electric vehicles are powered by electricity rather than any fuel, which means that they does not produce any carbon emission to meet the environmental challenges. Carbon contributes to the greenhouse effect and is known as the most important long life forcing of climate change. Means this carbon
This carbon
contributes the
contributes the
greenhouse effects and have the challenges of climatic changes. The greenhouse effect is when the atmospheric dioxide trap heat which leads to an increase in the temperature of the surface. History of electric vehicles.
History
Here
of
is
electric
the
vehicles.
small
Here is the
history
small
of
history
origin of the electric
of
vehicles.
origin of the electric vehicles.
1828,
In
the Hungarian
1828, the Hungarian
physicist
priest and
Annoy
physicist
Zedlik
Annoy
invented an
Zedlik
early type of
invented an
electric
early
motor
type of
and
electric
created
motor
a small
and created a
model
small
car
model
by
car
his new
powered
motor.
by his new motor.
Between 1832
Between
and
1832
1839,
and
Scottish
1839,
inventor
Scottish inventor Robert Anderson also invented
electric
a crude
carriage.
electric carriage.
Further, in
Further,
1835,
in
Professor
1835,
Symbrandis
Professor
Strengthen of Groningen
University,
Netherlands,
University,
and his assistant
Netherlands, and
Christopher
his assistant
Becker
Christopher
from Germany
Becker
also
from
created
Germany
a
also
small-scale
created a
electric car
small-scale
powered by
electric car
no
powered by
rechargeable
no
primary
rechargeable
cells.
primary cells.
Now
Now we
will
will
move
move
towards
towards
the
the
types of
types of
electric
electric
vehicles.
vehicles.
Electric vehicles
Vehicles
have
have
different
different
types.
types. First of all, we'll discuss about the battery electric vehicles.
The
The
battery
battery
electric
electric
vehicle
vehicle that exclusively uses
chemical
chemical energy
is
is stored in rechargeable battery packs with no secondary source of propulsion. For example, hydrogen fuel cell, internal combustion engine, etc. Battery electric vehicles store electricity on board with high capacity battery packs,
and
and
their
their battery power is
used
used to run the electric
motor
motor
and
all
onboard
onboard
electronics.
electronics.
Electric
Electric
vehicle
vehicle
charges
charges
are
are classified according to the speed
with
with which they recharge an electric vehicle's battery. Further,
next type that is
next
the plug-in
type
hybrid
that is the plug-in hybrid
vehicles.
electric vehicles.
A plugged-in
A
hybrid
plug-in hybrid
electric
electric vehicles
is
is a hybrid electric vehicles whose battery can be recharged
by
by
plugging
plugging
a
a charging cable
into an external electrical power source.
power source. In addition,
internally
to
by its
internally by its
combustion
onboard
engine
internal
powered
combustion engine
generator.
powered generator.
A plug-in hybrid
A plug-in
won't take
hybrid
into
won't take
gas
into
tank
your
until the
gas
battery
tank
runs
until
out
the
of
battery
power.
runs out of power.
Instead of electric motor
Instead of electric
engine
motor
working
and the engine working
at the same
together
time,
at the same time,
plug-in
a
hybrid
plug-in hybrid
uses
uses its
engine as
engine as
backup
backup
plant.
plant.
Hybrid
Electric vehicles.
Hybrid
Hybrid electric
vehicles have
have
an
an electric battery and a combustion engine.
The
The electric battery is charged using the combustion engine. Modern heavy electric vehicles make use of efficiency improving technology
such
such
as
as regenerative brakes, which also converts the vehicle's kinetic energy into electric energy, which is stored in battery or supercapacitor.
Many heavy electric vehicles reduce the idle emissions by setting down the engine at idle and restarting it when needed. It's known as start-stop system. There is a pull for electric vehicles. The coming decade is expected to the decade of the fully electric, with battery prices reportedly falling 73% since 2010. Electric cars are expected to be as cheap as fuel-powered cars in the foreseeable future. Currently, cars and trucks add up to 25% of the world carbon dioxide emission, which is harmful for our environment and the greenhouse effect. With the limited amount of petroleum gas, prices are always going to rise. These are the conventional sources of energy, and once time will be go up, and it will getting the shortage of the conventional fuels. So we have to opt certain fuel energy systems or the energy sources which are not the conventional and having some without the greenhouse effect, without the environmental effects. So the electric vehicles are getting the popularity. There are greater awareness about the effect of carbon dioxide in today's society. The world's leaders is trying to reduce the carbon dioxide emission by half by 2030. By 2025, 20% of all new cars, bikes, and large trucks sold globally will be electric. According to the latest forecast by the investment bank UBS, that will lead to 40% by 2030. And by 2040, virtually every new vehicle sold globally will be electric. Future statistics of electric vehicles. Here are the graphs, and you are looking at millions projected cumulative sales of electric vehicles, and it is in different sectors. Providers, government organizations, personal users, and other sectors. The popularity of electric vehicles are increasing. And this is the graph which 2025 is drastically changes the electric vehicles selling. How does electric vehicle work? Electric vehicles can work by replacing a combustion engine with an electric motor. That traditionally we know the internal combustion engine having the fuels and converts the chemical energy into the mechanical work. So those kind of combustion engines we are removing because it is emitting the hazardous gases, carbon dioxide, carbon monoxide, nitrous oxide, and various other contents which are hazardous for the environment. That's why while you are replacing the combustion engine, you have certain mode of generating the power to run the wheels on the road, that is an electric motor. Electric car functions by plugging into a charge point and taking electricity from grid. They store the electricity in rechargeable batteries that power an electric motor which turns the wheel. Electric cars accelerate faster than vehicles with traditional fuel engines, so they fuel lighter. This is the block diagram for electric vehicles. Here, the engine, which is the conventional internal combustion engine, giving the transmission to the wheels, and when this source of energy means the chemical source of energy, which is getting from the traditional fuels, now we're replacing by the batteries. Battery is the creating the current, which inverter converts to the required and transferring towards the motor or the generator, and then motor and generator will drive the wheel on the ground. Next, this is the hybrid system having the IC engine as well as the electrical sources. And parallelly, you may run with the battery sources. So charging system should be there. Electrical energy will be stored in the battery in the form of the chemical energy, and controller will control the electric motor and run that electric motor and getting the mechanical work by converting this electrical energy into the mechanical work. Advantages of electrical vehicles. An electric
car can be great for you. As a consumer, save a lot of money on gas. However, there are no many different reasons why we should invest in an electric
vehicles in the modern day
technology.
Advantages of
Advantages of
First
electric
of all,
vehicles. First of all, the nearly 100% recyclable battery,
and the cheaper to run
and the cheaper to run because of low rates of electricity than petrol.
third one
And
that is
third one, that is a reduced noise pollution because the movement, the mechanical parts, motions are removed
because
because the energy, there is no requirement of the internal combustion engine where the combustion takes place and noise created. So the noise pollution also reduces. Performing better performance, zero harmful emission because no carbon dioxide emission because the fuel is not in combustion stage
as
as
in the
as the petrol or fuel or gas, which burns that ultimately they
emitted the carbon dioxide
emitted the carbon dioxide plus heat energy, and that converts into the mechanical work and runs the wheels.
So
when you are not using the conventional fuel, then the harmful emissions will reduces. Lower maintenance due to an efficient electric motor. No gas required. Electric vehicles are entirely charged by the electricity
you provide, meaning you don't need to buy any gas ever again. Driving fuel-based vehicles can burn a hole in your pocket as prices of fuel have gone all time. Conventional fuels are getting rise in their prices. That's why there should be alternate options to run your vehicles, and that is the electric vehicles. More convenient. The electric vehicle is easy to recharge, and the best part is you will no longer need to run the fuel station to recharge your vehicle before hitting the road. Even a normal household socket can be used for charging an electric vehicles. Means source of energy. It is very convenient for the electric vehicles. You should not go to the petrol pump and make a queue and getting the fuel frequently. Savings. These vehicles can be fueled for very low prices, and many new electric vehicles will offer great incentives for you to get money back from the government for going green. Electric vehicles can also be a great way to save money in your life. This government is also promoting the electric vehicles to meet the challenges, environmental changes due to the greenhouse effects. Next, no emissions, popularity, safe to drive, cost effective, low maintenance, reduced noise pollution, battery life and cost, easy driving. This is a comparison between the electric versus gasoline. No tailpipe emission means in conventional engines, you will emit the harmful gases to the environment, and which affects the increases the greenhouse effects and ultimately having the challenges for the climate change. Range is also there. Hours to recharge, minutes to refill. Means electric vehicles have some comparative disadvantage that you have to pay the time for recharging, but you can refuel the fuel in minutes. And the comparative cost is as in manner that cost of electric vehicle is less, fuel cost is less as per the gasoline or the petrol or conventional fuels. Arguments, disadvantages against electric vehicles. Electric vehicles are too expensive. Electric will go up. Range of car is too short. Some of the purpose technology is not realistic. Electric fueling stations are still in development stage. Frequent changing of battery is required. Actually, electric vehicles are in modern trend, and it is in developing state. That's why there are certain challenges. Means as the technology upgrades or modified, then it will become more efficient as compared to the conventional fuel system engines. So currently, there are certain disadvantages that electric fuel stations are still in developing stage. Means everywhere that is not available. You should have the less opportunity to charge the engines or battery as compared to conventional fuels. So when we will overcome these challenges, then it will become the popular, and the technologies goes up, then it will be the more efficient and more performing and better to opt for the consumers. Conclusions. Electrical vehicles are definitely more environmentally friendly than internal combustion vehicles. Batteries are being engineered to have a long life. When the electric vehicles become more widespread, batteries recycling will become economically possible. Research into their energy sources such as fuel cells and renewable fuels makes the future look brighter for the electric vehicles. Here, the conclusion shows that we are in developing stage, in invention stage. A lot of research is required in this field, but when to start, we see it is the right time to start to opt the electrical vehicles, because the conventional fuels creates the environmental hazardous, and the cost is also the challenge because it is rising and the consumption of fuel is also rising. So we have to uh, see the additional means certain parallel solutions for the energy source, and that is the electric vehicles. Thanks for the listening for electrical vehicles, and over to Dr. Raju Jain for next session.
Thank you, Dr. Kinkar, for your insightful talk on electrical vehicles. Now, the second part of this webinar. Now we are coming to hydrogen vehicles. So the title of this particular lecture is Harnessing Hydrogen for Power. So we are going to use hydrogen as a power source in vehicles. So what exactly is a hydrogen vehicle? In a hydrogen vehicle, its primary source of power is from breaking down hydrogen. The use of hydrogen is usually happens to be two methods. First method is hydrogen can be burned much like the combustion reaction that takes place in the gas powered cars seen today. This is called an internal hydrogen combustion engine, or hydrogen can be set up to react with oxygen to produce water and electricity. This is called a fuel cell. So two technologies are there. One is engine technology, another is fuel cell technology. Now, benefits of the country of using hydrogen. It is lessen the dependency upon the foreign oil or fossil fuel, achieve lower prices at the fuel pumps, and cut down on greenhouse gases that produce global warming. Which car is best for environment? Now we have three types of cars with us. First is gasoline fuel car, which is very popular. We are using these cars nowadays. Another is hybrid car or pure hydrogen cars. Now, alternate fuel vehicle, two types of vehicle are there. One is hybrids or another is ethanol based. So hybrid vehicle, these vehicles are now but still require gas because they use gas as well as other sources of energy. Whereas this ethanol vehicle, now we are in India itself, we are going more than 20% ethanol in our fuel, and we want to achieve 100% ethanol fuel. But it is more expensive since the technology is not sustainable yet. Now, alternate fuel vehicles, one more type of vehicle is internal combustion hydrogen. It is the slightly modified form of internal combustion engine. It burns hydrogen, produces pure water exhaust, and it has serious range problem. This BMW has broken several speed records, but range is still a problem. Now, hydrogen cars offer the promise of zero emission technology. The only byproduct from the car is water vapor. When hydrogen is mixed with oxygen, the only byproduct is water. Now, the few of the pollutant fossil fuel burning vehicles emits are carbon dioxide, carbon monoxide, nitrous oxide, ozone. All are very harmful to the environment. Fossil fuel automobile emit 1.5 billion tons of greenhouse gases per year. Hydrogen-based transportation could eliminate all this. Hydrogen cars and fuel cells, two technology are there. So major car companies today are focusing on fuel cells instead of hydrogen internal combustion engines because it is thought that fuel cell will be more efficient and produce power in even cleaner way. Instead of burning fuel in an engine, fuel cells are electrochemical energy conversion devices. Fuel cell convert hydrogen and oxygen into water and along the way produces electricity. So more or less, by using this fuel cell, it is again a electric type of vehicle, you can say. So why fuel cell? So you can say you can see this particular figure: battery for high fuel economy and low emission, diesel engine, long range and fuel efficiency, and fuel cell is giving the advantage of all type of engine: high fuel economy, low emission, and long range as well. Now, these are the sources of hydrogen from crude oil, coal, natural gas, nuclear, solar, hydro, wind, wave, geothermal, wood, organic, and they need different type of technology to convert to get this hydrogen. Like crude oil, coal, or natural gas, we want reformer, we want electric power plant from nuclear that will go to electrolyzer. Then solar, hybrid, wind, wave, we need generator. Geothermal, we need power plant, and again wood, organic waste or biomass reformer for this. So we can have this hydrogen from very sources. Now, way of getting hydrogen: water is covalently bonded, so energy is necessary to break this molecule apart into the hydrogen and oxygen. So one process is electrolysis process, where water and electricity, separating water by using electric current, we get hydrogen and oxygen, like in batteries, electrical outlets, which is source of fossil fuel or renewable energy. Another process is thermolysis, where heat is given to the water and water is break into hydrogen and oxygen, like in solar panel. Other molecules with hydrogen can be broken into their component with added energy. Again, biological sources are there, like algae. It is deprived of sulfur that will produce hydrogen in a bioreactor, or hydrogen comes from hydrocarbon or from crude oil, you can say. Now, the projection of hydrogen, electrolysis is a method that produces 8 kg of oxygen for every kilogram of hydrogen. We don't need pure water to extract hydrogen, so why not we use this wastewater? But it is better, why not turn our waste into the profits? Many more ways to do it. So water, we need water for this producing hydrogen. That could not be clean water. So we can use wastewater to convert this water into the hydrogen and oxygen. So these are this is a brief history of fuel cell. In 1839, Sir William Grove invented the first fuel cell called a gas voltaic battery, and still 50 years later, Ludwig Mond and Charles Langer coined the term fuel cell. Now, hydrogen fuel cell, it is an old idea whose time has come. Fuel cell invented in 1938 by Swiss scientist Christian Friedrich Schonbein. Aspect of engine as well as in battery: no pollution emitted, PEM fuel cell, ideal for light duty vehicles and buildings and much smaller applications. Now, how these fuel cells work? Fuel cells are like batteries. The type of fuel cell highlighted today use a constant flow of hydrogen to produce energy. In this, a reaction takes place between the hydrogen and oxygen that converts the energy release into usable electrical energy. the most common fuel cell is one that runs off of proton exchange. This exchange takes place in the proton exchange membrane or PEM. This PEM is very much popular nowadays. Now, this is a figure of a fuel cell. It is very similar to the battery, but designed for continuous replenishment of energy via external fuel. Many different type of fuel cell. Most common will likely to be the PEM fuel cell. Hydrogen and oxygen in water, vapor, and liquid water out. Typical output is about 0.8 volts. So this is a fuel cell for 0.8 volt. Now hydrogen to the water. In the cathode, oxygen is ionized. In the anode, hydrogen is ionized, and these two ions, they make water. When these elements combine, energy is given off in electron form and gives off power to run an engine, and the water is also produced. Now, how this energy is made? Hydrogen gas is pumped into anode. The platinum anode acts as a catalyst to a reaction that ionizes the gases. The ionization reaction breaks hydrogen atoms into hydrogen protons and electrons. Ions are attracted to the cathode but have two ways of getting to it. Proton pass through the membrane and electrons are forced around the membrane, thus releasing the energy. So this is a figure for it. Now, function of a fuel cell. You can very well see. So this is how energy is made in an electrolyte membrane. Now this is a reversible fuel cell or electrolyzer. So hydrogen, we need storage option also. So we have two type of option. One is known as physical storage and another is chemical storage. Physical storage is refuelable on board. It is compressed hydrogen, liquid hydrogen, and its combined solution. Probably slide is not moving, so I am just rotating again. Just see these slides for a moment. ये कर लो, उसमें नहीं कर लो. So anyway, now this physical storage, it is refuelable on board. So compressed hydrogen, liquid hydrogen, and combined solutions. This is for physical storage. And another type is chemical storage. First one is refueling on board, another is non-refuelable on board. And refuelable on board is metal hybrids, carbon-based materials, and other materials. Now, storage and efficiency. So there are two storage options. First is produce the hydrogen on ground and then store in on-board the vehicle, like direct hydrogen option. Another is produce the hydrogen on the vehicle by means of a tiny onboard hydrogen plant. Hydrogen FC2 two times as efficient as internal combustion. Now, internal combustion efficiency 15 to 25%, and hydrogen fuel cell is 50 to 60%. This is estimates that FC vehicles can achieve equivalent of 80 miles per gallon of gasoline. Now, these are the fuel cell stacks. In order to produce enough voltage, cells are grouped into stacks. A hydrogen fuel cell automobile would have at least 45 cells in a stack, and hydrogen is stored and injected in either liquid or in gas form. So many cells, but not only output is still liquid and water vapor. So application of fuel cell technology is obviously in car, buses, space travel, exploration, airplanes, submarines, off-grid power supply, combined heat and power. What about compressed hydrogen in the cars? It is a serious issue. Simulation comparing severity of a hydrogen and a petrol weapon fuel leak and ignition. The right one is hydrogen one, since it's a compressed fuel cylinder. Now, fuel cell vehicle issues, storage is complicated. Hydrogen storage is very much complicated. The range is limited. It is expensive fuel. It's still a fossil fuel, as we are getting hydrogen from fossil fuel itself. And it's the energy carrier, not energy source. And it has a serious infrastructure problem. So, infrastructure means we need hydrogen production. Almost all of the hydrogen produced in the US today by steam reforming of natural gas. So we can say it is again a dirty fuel. Produce hydrogen directly from the new nuclear power, it's a good fuel. And R&D into several new methods like biological water splitting, photoelectrochemical water splitting, reforming of biomass and wastage, solar thermal water splitting, and renewable electrolysis. Again, another thing is how to get this hydrogen. So the hydrogen highway, the world first hydrogen refueling station opened in Iceland in 2003. California, Florida have both approved funding. BC Hydrogen Highway will link Vancouver and Whistler by start of 2010 Winter Olympic Games. But this is all from the US. In India, we are still very, very primary stage of using all these hydrogen fuels, though we made a train. Yesterday itself, it was announced that we made a green hydrogen train. Now, environmental, why we are pursuing hydrogen FCVs? Because it is emission free and the cost of associated with the environmental changes, it is very, very less if we go for this FCVs. Economics is, it is current projection, it is several times the price of standard car, and flexibility of oil industry, manipulation of supply to keep oil just cheap enough. At what point does it become worthwhile to the consumer when cost of gas, environmental cost, and dependency cost, and it should be greater than cost of fuel cell car plus hydrogen vehicles. So this is the economics. Again, these data is from some other countries, USA, Europe, OPEC, pharma. So supply and demand, it is nearly only two ways to reduce our dependence on the foreign oil is increase production and decrease demand. The push for hydrogen fuel cell technology in car represent the second one. So are we at hydrogen is only type of energy that we can provide a wholesale substitute of foreign oil within a decade. Clean, twice as efficient as internal combustion and plentiful. But like manned space flight in early 60s, hydrogen fuel cells are proven but primitive. Do we need another 10-year goal another 10-year goal to implement all this technology? Currently, several times more expensive. Fuel cell, no doubt, energy and clean bioproducts. On the cathode side of the cell, oxygen is being fed where it is then converted to oxygen ions. When the hydrogen protons and electrons reach the cathode, new products are formed due to the bonding of the ions. The waste products are water and heat, and this is the beauty of this fuel cell. So advantage is zero emission, no dependence on foreign oil, ability to harvest solar and renewable energy, not many moving parts in the vehicle, mileage before things start breaking, and hydrogen weigh less than gasoline. Price tag is the drawback of hydrogen car. Hydrogen supply, at this time, there are very few stations that supply hydrogen cylinder to power a car. Also, the price for the hydrogen is comparable to gas is, however, it takes 2 or 3 times as much as to power a car. As of now, it is very expensive to equip a car with a hydrogen fuel cell. Hydrogen is expensive to make, store, and transport. As of now, in a fuel cell, the center is a platinum plate, which is very expensive. As far as efficiencies are concerned, hydrogen fuel cells are over 50% efficient. Fossil fuel powered car at 10 to 20% efficiency. Hybrid power car has 30 to 35% efficiency. Ethanol is less efficient, but the fossil fuel, ethanol gets 20% less MPG than fossil fuels. So in the hydrogen car forefront, President Bush started a national program called Hydrogen Fuel Initiative in US. In India, we are still going for these programs. Ready or not, but fuel cell are coming. Fuel cell in mass transit, you can see hydrogen prototype body for AC transit fuel cell bus. Package for 40-foot bus, suburban coaches, and articulated transit buses. So if we go for comparison, near term, mid term, long term, and reduce vehicle emission. So ICC technology increase vehicle fuel economy, then hybrid vehicles, and then hydrogen fuel cell. At last, solar-driven Stirling cycle heat engine. It is functioning in hydrogen model. Uses concentrated solar energy to run an external combustion engine. The engine drives a small generator, typically producing from 5 to 25 kilowatts of electrical at peak. Stirling engines, together with their solar concentration and small and portable, and can be sited near electrical loads. The Stirling engine also can be powered with natural gas or propane, so energy can be produced even when the sun isn't shining. More than 100 million watt hours of renewable energy have been delivered to the public grid using the engine to drive electrical generator. So fuel cell vehicle being pushed by car company themselves. Some car companies I have listed here: Ford, GM, Honda, Nissan, Toyota, Hyundai, WV, Mazda. Other company, all are working on these fuel cell vehicles. Company getting involved for car as far as concerned. So Ford, Honda, BMW, Mazda, General Motors, they already have some models. So this is all about hydrogen vehicles. Now we are comparing our these two technologies, EVs and hydrogen, and try to understand which technology will sustain in future.
Thank you, Dr. Jain.
I'm just sharing one more slides. Few more slides are there.
Okay.
Now, EV or hydrogen vehicle, the question is which technology will sustain. So this is the agenda: introduction, evolution of mobility, EV technology, hydrogen vehicle technology, manufacturing perspective, cost and infrastructure, environmental impact, global trend, India's position, comparative analysis, future outlook, and conclusion. Transport sector is rapidly evolving, as we know, focus on sustainability and carbon neutrality. It is on focus. EV and hydrogen are the two major alternatives with us, and industries are investing heavily in both technologies. Why this topic matters to production division? It involves advanced manufacturing technology, impact industrial infrastructure, requires supply chain transformation, and influences future production planning and investment in this productivity and production. Now, global energy transition is there. Government targeting at net zero emissions, shifting from fossil fuel to clean energy, automotive sector under transformation, and strong policy support worldwide for this shift. What are electric vehicles? Professor Kinkar, he gave a presentation. The salient point is vehicles powered by electrical motor, use rechargeable battery system, and the examples are car, buses, and two-wheelers, and types are BEVs, hybrid, or plug-in hybrid vehicles. Now, EV vehicle principle is it is electricity stored in batteries and battery powers electrical motor. Regenerative braking improves efficiency and charging through external power source. So, key component of EVs are batteries, that is lithium-ion battery, electric motor, power electronic, charging system, and management systems. And advantage of EV, as Professor Kinkar said, high energy efficiency, lower running cost, zero tailpipe emissions, reduced noises pollution, and simpler mechanical structure. Now, the challenges in EV production is high battery cost. Battery is an important component and the battery cost is very high since we need more than one battery everywhere when we use this electrical vehicle. And lithium and rare earth dependency on this battery. It is very much there, and charging infrastructure limitations, and battery disposal and recycling issue. These are the very challenges what we are facing in EV production. Now, as far as hydrogen vehicles are concerned, as I told you, vehicles are powered by hydrogen fuels. Most fuel cell electric vehicles and generate electricity using hydrogen, emit only water vapor. The working principle, hydrogen stored in tanks, fuel cell convert hydrogen into the electricity powers electrical motor, and water released as a byproduct. Now, key component of these hydrogen vehicles are fuel cell stacks, hydrogen storage tank, electrical motor, power control unit, and cooling system. Now, advantage of hydrogen vehicle is faster refilling as compared to EV. It is very slower and longer driving range is there, suitable for heavy transport and lower dependency on battery minerals. Rare earth is nowadays an issue. How to get this rare earth? Most of the countries, they depend on China. So China is all these markets dependent on China itself nowadays. Now, challenges in hydrogen production is expensive hydrogen generation. Hydrogen generation is expensive. Using limited infrastructure, storage and transportation complexity, and lower energy efficiency. Now, if you go for manufacturing perspective for EV, battery gigafactories are required. Very big factories are required. Large scale semiconductor demand, localization opportunities are there, but this production is automation friendly production. As far as manufacturing perspective of hydrogen is concerned, specialized fuel cell manufacturing is there, high pressure tank production required, need for hydrogen ecosystem and complex storage technology. If we compare these two infrastructure, so EV require charging station, hydrogen require refueling station. EV infrastructure going faster, hydrogen setup cost is higher nowadays. If we go for cost comparison, EV currently cheaper to operate, battery prices declining rapidly, hydrogen fuel remains expensive, infrastructure investment higher for hydrogen. So this is cost comparison nowadays. We can't say in future how this cost of hydrogen infrastructure will come down. Now, if you go for efficiency comparison, EV efficiency is around 70 to 90%, hydrogen efficiency is 50%, 35 to 50%. So it is comparatively lower. Energy losses in hydrogen conversion are there, and EV currently more energy efficient. Now we go for environmental impact. So EV emission depend on electricity source. If electricity source is clean, so your EV is clean, otherwise it is dependent on electric sources. Hydrogen can be green, blue, or gray. The type of hydrogen you are making, whether you are making it from fossil fuel or solar energy. So if you are making hydrogen from solar energy, so it's green, otherwise it's gray. Green hydrogen has strong potential, and recycling remain critical for this, both the technology. For fuel cell too, and for batteries, recycling remains very much critical. Now the safety concern is there. EV battery fire risk. Hydrogen is highly flammable. Advanced safety system required for both of the technology, and strict production standards are necessary for both the technology. Now, what are the global trends? China leading in EV manufacturing, Europe investing in green mobility, Japan and Korea promoting hydrogen, Tesla, Toyota, Hyundai leading in innovation, and India, we are going for solar energy. We have a very good amount of solar energy nowadays, and up to 20, now it is 150 gigawatt, and up to 2030, this capacity will be more than more than half. It added 50% more in 2030. Now, India position is there. Rapid EV adoption in India, government intensive are there under FAME scheme, National Green Hydrogen Mission launched, and strong localization opportunity. We are working on both the technology, EV as well as this hydrogen technology. So application areas are there. EV suitable for urban mobility, hydrogen better for heavy vehicles. Public transport opportunities for both the vehicles, EV and hydrogen as well, and industrial logistic application. So hydrogen is better suited in heavy vehicles, public transport opportunities, and industrial logistics. So the question remains, which technology will sustain? So EV likely dominant in passenger vehicles. It is likely dominant, and hydrogen has promising for heavy industries. Both technology may coexist. Sustainability depend on infrastructure and cost. How these costs will come down in future, and how one country can create infrastructure for a particular technology. So sustainability will depend on these two. So the future outlook is, we need continued battery innovation and growth of green hydrogen economy. We now need smart manufacturing integration and strong government policy support. So the conclusion is, EV currently has a stronger market moment. Hydrogen has strategic long-term potential. Production sector plays a key role, and balanced investment approach is recommended. Thank you very much. If there are any question, please ask.
Thank you, Dr. Jain. We
Yes.
have two keynote. We have two keynote speaker, Dr. Rajiv Jain and Dr. Pramod Kenkar. Both are tell us about the environmental friendly automotive powered technology. Dr. Kenkar tell us about the history and current scenario of electric vehicle and types of electric vehicle, need of electric vehicle, and future statics and electric vehicle growth, working of EVs, and advantage and disadvantage of EV. And Dr. Jain also tell us about the another environmental friendly technology, hydrogen powered vehicle. It is the zero emission technology, and he tell us about the why fuel cell technology is advantageous for environment and its advantage in working of hydrogen vehicle, and tell us about the hydrogen storage options and disadvantage of advantage and disadvantages of fuel cell technology, economics of hydrogen vehicles, and as well as which technology is sustainable he tell about the comparison of EV and hydrogen vehicle and production challenges and marketing challenges. Thank you both for give us the insight knowledge for our audience. Now we can start question answer session. If anyone have doubt, please you can freely ask to our speakers, search chat box, or you can use chat box. Anyone can having any question, please speak.
Or alternatively, you can send a mail to us. So we'll revert on that. Our service there.
Evening,
Could we
everyone.
continue?
On behalf of JLC, the Institution of Engineers India, it's my proud privilege to propose the vote of thanks at the conclusion of today's insightful webinar on EVs and versus hydrogen vehicle, which technology will sustain. First and foremost, I extend my heartfelt gratitude to our distinguished panelists, Dr. Raju Jain and Dr. Pramod Tinkar, for sharing their valuable knowledge and expert insight. Their repeated presentation provide us with a clear understanding of the emerging technologies that are shaping the future of road transportation as sustainable alternatives to petrol and diesel-powered vehicles. I am confident that today's discussion has established our understanding of the opportunities and challenges associated with both EVs and hydrogen-powered vehicles. I express my sincere appreciation to Dr. Anand Vishen, who is skillfully moderated webinar. His well-planned coordination and engaging instruction made the entire session informative, lively, and meaningful. I also convey my heartfelt thanks to all the participants who registered for and attended the webinar. Your participation and thoughtful engagement made this program a great success. We hope that today's deliberations prove beneficial to understanding the future of insights are new technical support for the successful conduct of appreciate dedicated efforts of the entire GLC IEIB team for planning, coordination, and hard work ensured the smooth organization of the event. Once again, I thank our eminent speakers, moderators, participants, the headquarter teams, and everyone who contributed to make this webinar effective. Thank you all. Stay safe, stay healthy, and have a wonderful year.
Okay.